Hey guys, this is different in case you didn't notice. So I've never done this before, so hopefully it turns out okay and you guys can all hear this and see this. I'm here on the Desmos Calculator, and so you guys obviously want to make your way there. Today, really, your work is just going to be to play with this and to just kind of see how this works and stuff like that. So over here on Desmos, if you guys take a look over here on the screen, um, we can, and I got to make sure I tell you guys as I'm doing this stuff. So if I wanted to make a scatter plot on here, I can go ahead and do that. I'm just going to type table in, and then notice it says x1 and y1. I can plug in as many values as I want here and just keep going. So like on your homework, some of them are going to be, make a scatter plot on some sort of electronic thing. Notice as I am putting these in that you can see them over here on the graph. You guys all see that. And I'm just kind of making these values up. We just want a scatter plot kind of thing going on, and then we can talk about what we're doing from there. So like I said, I just hit table, and then we'll do one more. Let's do 8, 19. All right, so as you can see over here, we have our table of values. We can zoom in, we can zoom out. And this is just some scatter plot, right? Looks like it has a positive relationship. Yeah. So there's some cool things that we can do here. And one of the things that we can do is we can make our actual line of best fit. So let me make sure this works here. So if you type in, this is like the tilde right here. And that didn't work. Okay. Let's see here. We want this data set. Oh, I think I gotta go y1 approximately let's see if this works, x1. There we go. So this little symbol here, do I need to put plus b or does it change it if I do? No, it doesn't. Oh, well, it tells me my b, so that's good. All right, so all I'm going to do is after I type in my data set, I'm going to type this in, and this is not an equal sign. All right, that's the most important part. It is a little tilde, and you're just going to type slope-intercept form here. But you need to, because we could have several different tables going on in the same data set. Like notice I can just turn all these points off and on, which is kind of cool. But down here, I need to make sure I put y1 and x1. So I'm defining those as this table of values. And if you notice down here, we have some cool stuff that's going on. All right. So it tells me the slope and the y-intercept of my actual line of best fit. So it's using, yesterday we talked about picking 2 points, finding your slope, finding your y-intercept. This is literally using, mathematical formulas to calculate your actual line that fits these points the greatest way possible. So there's your slope, there's your y-intercept. So our equation on this line, and I could graph it, it'll show up right on top. If I do y equals 2.35577x minus my y-intercept's 0.7 6, whatever. So notice that that line just changed because now there's a black line over top of it. Literally, I took those values from right here, the slope and the y-intercept. Now, something new for you guys today is this R value here. This R value is a correlation factor. That's it, correlation factor. And the correlation factor tells us how strong or how weak our correlation is, or our relationship or our association. And so basically this number is going to go from -1 to +1, depending on if it's a positive relationship or a negative relationship. The closer it is to 1 or to -1, the stronger the relationship. So notice this one is 0.99. That's a pretty strong relationship. That means that this is almost linear. It's almost a straight line. But it doesn't have to be, right? So let's show you what happens here. If I change some numbers up, let's say this is 3, this is 11, this is 5, this one's 19, this one's 6, let's see, 11, and let's say the 19 is really a 13. Nope, not 13. 17. We'll just leave it. Let's make it 20. Okay. So down here, notice that my scatter plot got a little bit more spread out, right? It's not just a bunch of lines in a straight point, or points in a straight line. So down here on our R value now, notice that our slope and our y-intercept changed slightly, but our R value is farther away from 1. And that's because our points aren't as close. Now they don't have such a direct correlation. They're a little bit more spread out. And so that's going to make our correlation value a little less. It's not quite as strong a relationship. Now, if they get real crazy, like, let me see if I put a 13 in there. 23, 13. Because that looked pretty crazy when I did that, I thought. Maybe not so crazy. If they get real spread out and they don't even necessarily look like they're positive anymore, like that, look how small our correlation factor is. The closer to 0 it is, the closer there would be to having no relationship in our data. So even though it looks like it could still be a strong or a positive correlation here, these outliers are really pulling it away from that. And so not quite as strong, okay? So this is how this is going to work. Now notice that once we have, this one has a really nice slope and y-intercept though. Let me put that back at whatever it was at, 13, sure. So notice once we have our equation here, so let's say I have y equals 1.27885x plus 5.15385. Once we have our equation here, we can find values, right? We talked a little bit about this yesterday. I'm not sure if I talked about it with you guys or just in class. But now I can calculate any value I want. So like, hey, what if x is 30? Well, I can plug 30 in here for x. I wonder if I can do just x equals. Well, this will help us at least. So x equals 30. I could plug that into my calculator and see what's going on. Or I can just type it in, and I can see that if x is 30, the y value here is going to be 43.519. And I could calculate any value that way, which is pretty awesome. Now you might want to say, like, why would you do that? Well, think of what people are using this scatter plot data for, right? Maybe I want to know, when is gas going to be $3 a gallon if it stays on the current trajectory it's on to if it keeps raising. when is the ozone layer going to be so depleted that it lets really harmful rays into our solar system? When is my company going to start making money instead of losing money? After I've started all these startup costs, when am I actually going to start finding a profit? These are all really good data analysis questions, and scatterplots are the way that we're going to get there. So people use this technology all day, every day. Really, it's an entire career. And so those are really the things I wanted to talk about. Being able to put a table in here, find that line of best fit. So that's really helpful for your test coming up, because you totally can use Desmos on your test. And on your state test, this is the calculator you're allowed to use. So if you know how to do this, then you can use this and find your line of best fit, which is fantastic. I wanted to talk about that correlation factor. The closer it is to 1 or the closer it is to -1, the stronger the relationship is. The closer it is to 0 on either side, the weaker the relationship is. The further away those points are going to be. And yeah, I think that's all I really need to talk to you guys about. We're going to get a review for our test here soon. And then, like I said, test is on Tuesday. But I have a couple for you guys to try. So go ahead. You're going to just set your tables up just like we did here. And then you can plug in your numbers from your data sets. And then you should be able to mess around with this and hopefully get your lines of best fit. All right. Let me know if you had any problems with this and you need help, or you didn't get it at all, and I can kind of walk it. We can zoom and I'll share my screen and help you out. Okay. All right. You guys have an awesome day.